Good morning. Today we'll discuss about the problems on cooling tubes. So before going to solve the problems on cooling tube, last class we have discussed about the cooling tubes of a transformer. Let us briefly explain that. So design of tank with tubes. Basically for any transformer, the temperature depends on the losses. So if the more losses, the more temperature will be there. For small capacity transformers, normal air will be sufficient. As the capacity of the transformer increases, losses and temperature increases. So to keep the temperature rise within the limits, air may have to be blown over the transformer, but it is not advisable because the air contains the moistures and some dust particles, so it will affect the transformer winding. So, so further as the capacity of the transformer increases, there will be a high dissipating area of the tank results, high dissipating area of the tank required. So for the high dissipating area of the tank, so the bigger size of the tank will be required. So this causes more space and volume of the vial and increases the cost and transportation problem. So to overcome this difficulty without increasing the size of the tank, and some artificial means we can give the sufficient cooling for the transformer. So the dissipating area can be increased by fitting fins to the walls. This is one method, and using corrugated tanks, fitting tubes to the tank, and using auxiliary radiator tanks. So we will basically we will use fitting tubes to the tank. This is the most economical method and efficient method. This we have seen that. And temperature rise in the plain tank. So the specific heat dissipation in the plain wall tank, they had been given 12.5 watt per meter square. It includes radiation and convection. Radiation is 6 watt per meter square, and convection is, due to the convection, is 6.5 watt per meter square centigrade. So dimensions of number of cooling tubes, we have derived the equation, the dissipating surface of the tank xt, and it will dissipate 12.5 st, where st is my surface area of the tank. I need to find. So dissipating surface of the tube x into st. So the let loss dissipated by tubes by convection is, so this much 1.35 into, so usually we'll take 35% more than that. So total loss dissipated by the tanks and tubes will be getting the surface area of the tank in 12.5 plus 8.5. This you will get from this. This yesterday we have seen this. And then finally theta is temperature equals to the losses Pi plus Pc. This will be iron losses and copper losses, and the loss dissipated will be given as surface area of the tank into 12.5 plus 8.8x. 12.5 is due to the convection and the radiation, and 8.8x will be given due to the 35% more than the convection. So finally you will get x value, and the total number of the tubes will be required is total area of the tube and by area of each tube. So the formula we have derived is number of tubes equals to 1 by 8.8 plus 1 by 8.8 of iron losses plus copper losses by theta st. Theta is my temperature and st is surface area of the tank, and minus 12.5. So pi dt into lt. Dt is the diameter of the tube and lt is the length of the tube. This finally will get number of tubes equals to 1 by 8.8 pi dt into lt pi plus pc theta into minus 12.5 st. Now usually the diameter of the tube normally used in is 50 millimeter, and they are spaced at 75. The diameter of the tube usually 50 millimeter, and they are spaced at 75 millimeter. This is center to center distance, and the total is 125 mm. So usually we will consider this only center to center distance. and the dimensions of the tank decided by the dimensions of the transformer frame and clearance required on all sides. Not only this, it depends on kVA rating, voltage rating, power factor, and the losses also. So this is my three-phase transformer core type. So this is the clearance between the winding and the frame, that we call it C4. This is the clearance between the ground and the winding of a transformer. This we have shown here. So this is my diameter of the distance between the one to the one of the transformer. So, and this is my diameter of the coil. So this has been given. So yesterday we have seen this. What is D was the outer diameter of the coil, outer diameter of the coil. So WT equals to 2C1 plus 2D plus DOC. How you will get WT means it is D plus D 2D, and D half of DOC and half of DOC, it is 1 DOC plus C1 plus C1 2C1. So you will get like this for three phase, and for three phase 3 limbs and single phase 2 limbs, and for length of the tubes and height of the so length of the tank and height of the tank has been given by these formulas. So while solving the problems you can know this. Now let us solve some problems on this. Yes, the first question is a tank of 1250 kVA, that means 1250 kVA natural oil cooled transformer has a dimension length, width, height. It's 0.65 meter into 1.55 meter into 1.85 meter respectively. That means length, width and height they had been given. A full load loss 13.1 kilowatt they had been given. Losses that includes PI plus PC, iron losses plus copper losses, and loss dissipation due to the convection due to the provision of tubes 40 degrees Celsius they had been given. Temperature rise 40 degrees Celsius, and length of the tube 1 meter he had been given, and the diameter of each tube 50 mm. If diameter of each tube is 50 mm, in the question if he had not been given, take 50 mm only. So what we need to is find the number of tubes for this transformer, neglect top and bottom surface of the tank as regards of the cooling. So we need to neglect the top and bottom portion. Let us say this is my transformer tank. So here this portion back of this one more portion will be the same, and similarly this is one portion. This portion from here to here, yes, this portion, it includes this also. So opposite to this one more portion will be there. So in the question he had been this is my WT width of the tank and length of the tank and height of the tank they had been given in the question, and the power of the transformer is 1250 kVA, and let us estimate surface area of the tank. What is the total surface area of the tank? So total surface of the area of the tank, this portion and the backside of that, and this portion and backside of that. So usually here top portion and bottom portion has been neglected. So only the tubes will be arranged in the sides. So now see, for this portion my area will be this is like a rectangular or square. So HT into WT, and the one more will be backside plus HT WT. Here this portion will be of again rectangular HT height of the tank into LT, and the same thing opposite side will be also there. So 2 times of HTWT and plus 2 times of HTLT, that had been given here, 2 HTWT plus HTLT. So 2 1.85 into 1.56, this is given in the question. So these values are these values. So as per the question, then from this we find out the surface area of the tank. It is 8.14 meter square. Next, now we need to find the area of the tube. Area of the tube is x into st, where we need to find, now we know that st, but we need to find x. So how to find the x? Let us, loss dissipated by the cooling tubes due to convection, 6.5 into x into st into 1.40. They had been given 40% instead of 30. In derivation we have seen 35%. Here in the question they had been given 40%. So 6.5 into my surface area of the tank is 8.14 and into 1.4 into x. So it had been given 9.1 x into st. So keep this st in this st form only. Now this is loss dissipated by the cooling tubes due to the convection. Now this is loss dissipated by the wall side tubes. So it is 12.5 st plus 9.1 x st. So by wall side combination of the wall side tubes, this is 12.5. It is due to the radiation and convection, and here it is 9.1. It is of the convection into st, surface of the area of the tank. So if you take common as st, so we will get this st 12.5 plus 9.1 x. So temperature equals to, as we know, total loss by total heat dissipated. So theta equals to pi by plus pc, pi plus pc, that is iron losses plus copper losses, that gives the total losses, and st, it is total heat dissipated. So you can find the x equals to, after applying all the values in this, so finally you will get x equals to 1 by 9.1, 1609.33 by 40 degrees Celsius. Theta is 40 degree. In the question he had been given minus 12.5. So finally you will get x equals to 3.04. Now you can find area of the tube. Area of the tube is 3.05 into surface area of the tank. So if you multiply, you will get 24.807 meter square. Then area of the each tube can be find out with the formula pi dt into LT. So pi here 150, my dt is, my LT is given 1 meter, and dt has been given, diameter of the tube is given 50 mm. So convert it into meter. So it becomes 10 raised to minus 3. So finally you will get 0.157 meter square. So number of tubes required is, we have a formula, number of tubes required is total area of the tubes and area of each tube. So total area of the tube and area of the each tube is 24.807. It is total area of the tube, and area of each tube is, so we will get finally 158. Now the question arises, how to fit this 158 tubes in the transformer tank. So how many tubes should be in the, how many tubes should be in this portion, and how many tubes should be in this portion, that we need to do. So usually, as I from derivation, as we know that usually the tube spacing between center to center is 75 mm. So here you can take, it is an lengthwise it is 1.55 mm, 1.55 meter. So if you convert it into millimeter, so it is 1550, and the length is 650 mm. So we need to place here and here. Now from this width wise, 150, 1550 by 75, will get the 20. So 20 tubes can be accommodated in a single layer. So lengthwise it is 650 and divided by 75 by, it gets 8. Now if you place, so total number of tubes is 158. Total number of tubes is my 158. So I need to place this 158 tubes in this portion, in this, and in this, and in this. So equally it should be arranged. So comes to this point. So 1550 mm divided by 75, you will get the 20. So 22 for in one layer, 20 tubes I have placed here, and next layer exactly I cannot place here. In between the gap I need to place here. So here 20. Again above that, again one should be you should leave some space here. Again 17 I placed here. There is no hard and fast rule, you need to place 17 only. Below 20 you can place in such a way that uh, it should not accommodate more than 20 tubes. So here 20, 20, 40, 57, and here also 57. So 57 plus 57, it is 114, and here I placed 8 tubes. So 8 plus 8, 16, 16 plus 6, it is 22, 22 plus 22, 44, 44 plus 114, you will get 158 tubes. So here I have placed 8, here I have placed 8. In above this I cannot place 8. Again, as you go on increasing layer by layer, your tubes should be reduced. So here I place 6. No problem here if you place 8, 8, 7, and here you can place 18 also. No issue. So in width wise I have placed here 54, and here 54, 20, 20, 40, sorry 57. So here I will place 57, 57, 57 plus 1 not 114. So here 22, 22, it is 44. So 114. Then coming to the second problem, a 250 kV 6600 volt bar 400 volt 3-phase core type transformer has a total loss of 4800 watts on full load. The transformer tank is 1.25 in height and 1.1 into 0.5 in plane. Design a suitable scheme for cooling tube if average temperature rise is limited to 35 degrees Celsius. Diameter of tube is 50 mm and spacing between the tube is 75 mm, and the average height of the tube is 1.05 meter. So here they had been given height of the tank, length of the tank, and width of the tank. Height of the tank is 1.25 meter, and length of the tank is 1.5 meter, and width of the tank it is 0.5 meter. Now surface area of the tank, as similarly how you solve the for previous problem, the same it is 2 into ht into wt plus ht into lt. Here also they are not considered a top and bottom portion. So you will get, after replacing all, after applying all values of ht lt wt, you will get a surface area of the tank, you will get 5 meter square, and loss dissipating by cooling tubes due to the convection is 6.5x into xst. This is x and st. Here I have written like this. So it is not like that. X and this is t. Like this it is. Yes. It is x into surface area of the tank into 1.35. This is due to the convection. So you will get 8.775. So the total loss dissipated by wall side tubes. So 12.5 st plus 8.77. Again you need to take common as st, then you can solve. So finally you will get x equals to 1.701. So area of tube will be given x into st as per the formula. So you will get area of the tube, it is 8.54 meter square. Then the area of each tube, it is pi into dt into lt. Dt diameter of the tube is 50 mm, and height of the tube, that is length of the tube, had been given 1.05 meter. So finally you will get area of each tube it is 0.164 meter square, and the number of tubes is, how many tubes if you require is total area of the tubes by area of each tube. So 8.54 by 0.164, 53 tubes. So these 53 tubes you can accommodate in length, widthwise and lengthwise as we solved in previous problem. So this you can like this. Leave it. Then the third problem is, so a 1000 kVA 6600 bar 440 volt 50 hertz 3 phase delta star connected core type transformer having a distance between the adjacent limbs is 0.475 meters. Outer diameter of HV is 0.44 meter. Height of the frame is 1.24 meter. Core loss is 3.7 kilowatt. Copper loss is 10.5 kilowatt. Improvement due to the convection is 35%. Temperature should not cross 35 degrees Celsius. Clearance between the winding and tank is 70 mm. Clearance on each side along width and length is 90 mm. Allow 50 meter for base and 300 meter. Allow 50 millimeter for base and 300 millimeter for oil above frame. Consider 300 mm for leads and length of tube is 1.4 meter. Diameter is 50 mm and spacing between the tubes is 75 mm. We will see this little larger problem. So let h will be the height of my frame, and DOC means outer diameter of the coil, and D equals to distance between the adjacent limbs. Now what is height of the frame, outer diameter and distance between the adjacent limbs? We will see. Yes. Now this is my distance between the adjacent limbs, capital D here. D is distance between the adjacent limbs. Clearly I will show you. Yes. So distance between the adjacent limbs D, and this is the my clearance from the bottom to the my coil. So that is C2, and this is my the clearance between the my coil and the tank, that is C1, and C2 is my distance between the above or distance between the coil and the transformer frame. So that is above portion per portion. So the total height of the tank will be this, and the length of the tank and will be this portion. This we have given here. Length of the tank has been given this portion. Now we will see how to find. Yes. Now WT is equals to width of the tank. So this is my width of the tank. So from here to here it is width of the tank D plus D, it is 2D, plus half of DOC plus half of DOC, it is 1 DOC, and here C1 and here C1. So it is 2C1. So the total width of the tank becomes 2D plus DOC plus 2C1. The same we had been given here. So 2D plus 2C1 DOC. So they had been given the distance between the, in the question he had been given distance between the adjacent limbs, it is 0.475 meter. So the same thing he had been given 0.475 meter plus clearance he had been given, distance between the wall and the tank he had been given 70 millimeter, and the diameter of the coil has been given 0.44. So you will get 1.5. So and the length of the tank they had been given 2C2. This length of the tank had been given, see here, C2 and C2, 2C2 plus H3. or H can be, yes, 2C2 plus DOC. Here they have been given length of the tank C2 and this C2 and this DOC. Here also it is same and here also it will be same. So C2 plus C2, 2C2 plus by DOC. So that we have been given here, right? So that by adding that you will get 0.62 meters. Then height of the tank C3 plus C4H. So height of the tank, so height of the tank has been given C3 plus C4 plus H. So this portion is H. So the same thing here, C3 plus C4 H height of the frame. So they had been given 50 into 10 raised to plus 300 meter plus 1.24. So totally you will get 1.89 meter. So from this find out the surface area of the tank. So surface area of the tank it is 2 into LT into HT plus W2. So you will get 8.808 meters. So loss dissipating is 6.5 x into ST and into 1.35. Here we have been taken 35% when you compare with the tanks and walls. So total loss by wall signed tubes it is 12.5 x 12.5 st plus 8.77 x st. So you will get finally x equals to 4.29 meter. So area of the tubes is x into st. So area of the tube you will get 4.29 into 8.808 x into st. So you will get 34.72 meters. So area of the each tube it is pi into d2 into lt. So length of the tube has been given 1.4 meter and the diameter of the tube for 50 into 10 raised to minus 3. So it has been given 0.219 meter square area of the each tube. So number of tubes it is total area of the tube is 34.72. So 34.72 and area of the each tube it is 0.219. So you'll get 157.8. So if you make the round figure it is 158. So as we done in the same way in the first problem. So here 1520 meters and here 620 meters. So similarly 20, 20 and 17 here we will accommodate in one side of the portion it will be 20, 20 and 17 and opposite to that the same 20, 20, 17. Usually however the layers will be increases the tubes will be reduced. Here also 8, 8, 16. So the opposite part also you will be having 8, 8, 6. Sorry, it's not 16, 8, 8, 6 and here of what 8, 8, 6. So totally 114 plus 44 it is 158 tubes will be accumulated. So thank you. This completes your transformer module. So in next class we will start for the induction motors, design of induction motor. Thank you.